Hello and welcome back. In this session I want to go over some of the workflow basics in R. This will admittedly be a bit boring compared to the last session where we talked about visualizations and got you quickly up and running, creating some beautiful plots in R from raw datasets. However, I think that probably you didn't fully understand what you were doing, and this is absolutely okay at this point. The session was meant to get you excited about your new skills, not to teach you in detail how R works. This is what we will try and tackle this time, where I hope you will gain some deeper understanding of how R works. And to get started with this, I first want to focus on the console again. So if you haven't changed the pane layout, this will be the window on the bottom left here. And I want to once again highlight R's capacity to function as a simple calculator. So we can simply type in some math here and R will calculate it. We can do a simple multiplication. We can let calculate 3 to the power of 3. We can divide 3 by 3. And we can also take the square root. And here for the first time, we need an R function. And as I said before, functions in R always look the same. You have the name of the function first, then you have an opening bracket, then what goes in are the arguments, and you close the function by closing the brackets here, telling R that you are done with your command and it should start executing it. However, you will almost never directly do this, but it becomes interesting once you can insert objects as well. So let's create an object called 3, and you can create objects in two ways. The bad way is to use the equal sign. So like this, we have an object in our environment now. The correct way to do this is to use the assignment operator. And you can either type it in, which are two different characters, or what's actually easier is to use the keyboard shortcut, which is the Alt key and the minus key. Now, these objects can be used exactly like the values they represent. So what we can do is, again, do a multiplication, or we can do a division. We can, again, do 3 to the power of 3. And as you can see, it works in the exact same way. Now we can also copy an object if we wanted to, using the exact same logic. We first type the name of the new object. Let's call it 3, 2. Then the assignment operator, and then the name of the old object. Now we have two objects with the same value, which of course doesn't make a lot of sense. But I just wanted to show you that if you wanted to, you can copy an object, and sometimes this is useful, for example, when you want to overwrite an object, but you want to keep a backup of that object in your working environment. What you can also do is to create a new object based on calculations done on old objects. So we could assign a new object called 9, and we want to base this off of a calculation of the object 3 multiplied with itself. And as you can see, the value is correct up here in your environment viewer. Now, if you wanted to inspect an object, there are basically two ways in R. You can either use the view command, which we discussed last time. It isn't available for all of the objects. So if we had a data set like the MPG data set, and we could copy this to a new object as well. Let's call this new object MPG new. And MPG is, of course, part of the tidyverse, so this didn't work here. But once we load the tidyverse, this should work now. Now, this object is a data frame, and therefore we can use the built-in viewer. You can see this by the little new symbol here, and if you click on it, as last time, it displays the data set in the spreadsheet-like viewer here. However, for most objects, and this here are different character vector, this here are different numeric vectors, we can't do something like that. What we can do though is to print this object, and we can do this either by explicitly calling the print function, or as a shorthand for print, we can simply add the name of the object here. And when we run this, like we would run any other R command, it will use the print function to display the value here. Now, what we're doing here is data science and not necessarily math, but the two are, of course, closely related, and where R's capacity to do simple calculations comes in really handy is when you want to change data sets on the fly. So something that was really bugging me last time was that we saw all of the values in miles per gallon, which to me doesn't mean a lot. And what we could have done is to calculate kilometers per liter instead. And the way you could do this is by simply adding the calculation here. So we had, of course, the displacement variable, which means the engine size in liters already, so this one is fine. But to get kilometers per liter, we can multiply the HWY variable with the value that, according to Google, converts miles per gallon to kilometers per liter, which is 2.35215. So just like this, you could get a plot that actually displays units that I personally find much more intuitive. Now, moving on, the book covers naming conventions, and there are very good reasons why it recommends that you use snake case for your object names. So snake case means that if you have two words, for example, you want to call an object new object, you could theoretically, and this is also pretty readable, use capitalization to do two words. And sometimes this was done in the old days of R, but it is, in my opinion, harder to read because in this case here, it's not super clear that new and object starts here. So it's just easier to replace the white space, because you can't have white space in your object names, but to simply replace it with the underscore character. So this can be really useful, especially if you have a few different objects. So we had the MPG dataset now, for example. So if we change that, we could name the new object MPG changed, or MPG converted, to indicate that we converted the imperial units to metric units. Something that is extremely useful in RStudio is the autocompletion, and I've shown this for functions already in the last session. But what you can see here is that if you type in the first characters of an object and then you hit the tab, then you hit the tab key on your keyboard, you get a selection of all the different objects in your environment whose names start with T and H, for example. And what you can see here is that since we've loaded the ggplot package, you get a lot of functions here which are indicated by the symbol in blue at the beginning. Then if you scroll down by using the arrow keys on your keyboard or using your mouse, eventually you will get to the objects, which are indicated by the red symbol in the beginning of the line. And here you can see now your two objects starting with th, which are 3 and 3, 2. And voila, you can print this object. Now, autocompletion is so useful because R is really unforgiving when you write code and when you write object names. So if you type 3 with a capital T, and RStudio actually automatically tells you, okay, probably you want one of those, and if you hit enter, it automatically changes this, like autocorrect on your phone. But if we force R to use the wrong object name with a capital T, then it will tell you that this object is not found, which means actually it doesn't exist in your environment. So if you get the error object something something not found, always check if you have a typo in your object name. This is most likely the reason for this error, or the other reason is if you've never defined an object of that name, the error will be the same. So let's say we wanted to print the object 7, which again doesn't exist. You will get the exact same error. You first had to define 7 with the assignment operator, and now by pressing up in the console, you can get to the previous commands, and printing 7 now obviously works. Make use of this autocompletion feature wherever you can, because it will save you a lot of trouble debugging errors where an object name wasn't found. And obviously here it's not that hard, but if you have a longer command with several objects in it, then you will struggle to find where you misspelled one of the object names. Moving on to scripts. I already briefly mentioned scripts before, but let's open a new one here to again briefly talk about some of the features of scripts. First of all, I wanted to say that the workflow that is described in the book is probably the worst you can imagine, which is you first type the commands in the console, and once they work, you copy them to your script. I mean, obviously you can do that. You can also use the history function here to copy to source if you wanted to. And RStudio will just do that. But it is very cumbersome, and you are very likely to forget to copy one of the commands you run in the console to the script, and then your whole script probably won't work. So, for example, if I started a new session here, and I just copied a few of the commands I just ran into the script, and then I wanted to run the script, obviously it wouldn't work because I forgot the command where I actually defined 3. So I think it is better to directly type all of your code into the script before running it. However, I think this is only the second best option that you can use. As I briefly said last time, I think that R Markdown is actually a lot better. And just to compare this two, let's open a new R Markdown document. And essentially, let's remove all of this. And essentially, both of these are rather similar. Both are completely flat text files, so you can open them in any text editor that you want. Both of them can use normal text to describe what you're doing, and also R code. But where the two differ is that for R scripts, everything that isn't specifically marked as text, which you would do by using the hashtag character, and then describing what you are doing. So say define objects here. You could do this. And then make calculations, for example. So you can use this, and then if we save this R script, let's call this test script.r. We can convert this to a document that ran all the R code and also shows the text by hitting Control or Command Shift and K, or by pressing this little button here. It asks you what kind of document you want the output to have. I'm choosing simply HTML here. And as you can see, you have some text here, and you also have your R code that is actually evaluated, and you have the results down here. Now, in an R Markdown file, the hierarchy is exactly opposite. So everything you write in here is normal text. And let's just use this. And if you want to run R code, you have to press Ctrl Alt and I to insert an R code chunk. And let's just recreate the R script in R Markdown. So the difference, as I said, is that only this will be evaluated as code, and everything that is not inside of an R chunk gets treated as normal text. So let's save this file. And this time we have to use the RMD ending. And knit this again. And you can see the text is now outside of the code chunks, but it's evaluated and looks a lot like the output from the R script. However, something that you can't do in a normal R script is to format some of the text. So as the name indicates, R Markdown is based on the Markdown language, which is a really simple way of formatting text, which is widely used. So for example, you can make a word italic by surrounding it with stars. You can see the output is now italic, and this is something you just can't do in an R script. Now, of course, when you get started with your own projects and when you work through the book, you can use R scripts as well as R Markdown files, whatever fits you best. But I would argue that every data science project needs some explanations, and I think those are easier given in an R Markdown file, and you can also use the Markdown syntax, which is quite powerful. For example, you can also quickly create a headline. And again, this is something that you simply can't do in an R script. While we are here, I also wanted to quickly highlight one of the best things in R, which is that wherever you put the cursor in your code here, RStudio will know what you want to evaluate when you hit the Run Code button. So, of course, here it knows you only want to execute the commands in line 2, but R is actually not very strict on how you format code. So what you could also do is to split this up into multiple lines, and when you set the cursor here, so in the second line, and again run the code, R still knows what you actually wanted to do, which is to evaluate this whole chain of commands here. Now, of course, you could also highlight the whole thing and press run again, and RStudio again will know exactly what you wanted to run here. You can also highlight a few different lines and run those. And this, of course, works no matter if you press the run button on top here or if you use the keyboard command, which is helpfully shown here and is Control and Enter, or on Mac computers, it's Command and Enter. Now, before we move on and talk about projects in RStudio, we need to cover something very basic about computers, which, depending on how old you are, you might not know. If you've grown up with Android devices or iPhones, then you're probably not aware that every computer is organized in a very specific way. The smallest organization unit of a computer is a file, and it can house everything from a single line of text to an incredibly large movie or a whole data set or whatever you want. These files are located in your system in so-called folders, which is a small collection or a large collection of different files, and these files are stored in a storage. So your computer's hard drive is organized as a storage which contains folders which contain files. And R can use a lot of different files, but it needs to know exactly where they are. Imagine R is a very capable assistant who is helping you with your work, but has no idea of your filing system, so it doesn't actually know your storage. It will do exactly what you want with your files, but you need to be very specific in telling it where your old files are and where you want to put your new files in. If you don't tell your assistant that, then your assistant will have no idea where to find anything and will complain that it doesn't know where your old files are or where you want to store your new ones. So to make this even more clear, let's look at this on a Windows machine and a Mac. So here we are on my Windows machine in a file explorer, and I started at the Documents folder, which for R is the home directory where it will start when you haven't specifically chosen any project. And just to show you how you get the path, so the explanation where a file is, you can simply click on that box up here and it will display the actual path to your file. In Windows, paths always start with the drive letter, which in this case is C, and then it uses a backslash to show the first folder. So it shows here that it starts with the user folder, then goes to my username, then documents, and then we go into this folder which are called data signs. We can create a new file here. For example, let's create a really easy one, which is a text file, and let's call this new file. And now we have this new file here. The path exactly explains where this file lies, and we can go to this computer and to the drive, which is the C drive. Then next we went to the user. Here is the user. Then we put our file in documents and data signs. And as you can see, we just clicked through the entire path and we are back at the data science folder where we placed our new file in. Now, for a couple of versions, Windows does a pretty good job in trying to hide this actual path. So for example, when you're in the documents folder and you click on the top here, it doesn't actually display the path, but it makes you believe that documents is a somehow special folder that exists in a vacuum. And the other thing is that by default, Windows hides parts of the file name. You can revert to the original setting, which isn't used for a couple of generations, by going into the options and then view. And then here there's an option that tells you hide extensions for known file types. This is selected by default, but if you remove this, you can see that actually this file is called newfile.txt, and the txt indicates that this is a text file. And now moving on to my machine running Mac OS, I started again in the folder where R usually starts with, which is my user folder. Here my user is called Yo, and it's located in users on my disk. Now again, I created a folder called data science, and here we have the new file which I created, which is an empty txt file. And we could open this in a new tab to see the start of the operating system, which is the disk location. And when we now go to users, Joe, data science, we are again at the exact same location. Now, you might not have this path down here describing where your file is located, but when your Finder is open, you can simply go to View and then enable the option Show Path Bar. Now, back in RStudio, you can see your current working directory just above the console, or you can also use the command get wd, so get working directory, to see where exactly R is currently looking for files. Now, we can create a file in this working directory, for example, using the write lines command, and we can simply use an empty character object, so character object with nothing in it, and then tell it that we want to create a new file, and we can start from the home directory of this computer, then my username, then we could use a folder called R data science, which already exists and which is actually currently my working directory. And then we can create a new file. Let's call this new file.txt. And even though on Windows machines the file extension is usually hidden, you always have to include it here. And the write lines command basically creates a new txt file with this empty character object here. Helpfully, RStudio also has a file explorer built in, and when we click on this, it opens the text file. So as you can see, it is completely empty. Now, when we talk about projects in RStudio, those basically have two advantages. First of all, as you can see here, I have several files open now, and these are linked to the project. So when I close this project now, you can see that those are gone, and instead the open script is the one I created in one of the very first videos where I first created the RStudio project. And the second difference is that my working directory now is this tilde, which when you check the get wd command again, I forgot the brackets, you can see that it is just the folder of my user. When you have files located not in your user directory, but for example in a Dropbox folder or on a USB drive or something like this, we would usually always have to write down the entire path to, for example, open the new text file that we just created. When you open a project, and you can of course switch through, you can of course have a few different projects in this menu here. Currently I only have the R data science project, but eventually you will work with a few different ones. When I switch to this, it will automatically set the working directory to the location of this file here with the ending .r project. This is really very useful if, for example, you have your entire project located again on your Dropbox in your Dropbox folder or on a USB drive, and then whenever you open the project, R will automatically start wherever you saved your files. This is of course an advantage, but I also wanted to let you know that it is not as important as it has been in the past, simply because nowadays you can use R Markdown files, and those even work a little bit differently and better, in my opinion. If I enter the get working directory command down here, you will see that it displays the same location, but if I saved this file to a different location, let's say I save it under downloads, and I run this command again, you can see here my working directory. So in the console, the path hasn't changed, but when I enter this here, you can see that it now displays the location of the R Markdown file. Let's switch back to the original test script. And the advantage now, if you're absolutely sure where your working directory is that you can use relative paths. So let's first create a new file and then we can load it. So I use again the write lines command, but this time I want to export the character object hello computer, and I export it to the file text file.txt. So what you would need to do when you wanted to read in this file is the read lines command, and you could enter the absolute path. And here again, you can use tab to get an autocomplete. And you have your text file here. So it reads the object back to you. However, what we can also do, since we know that this is located in the working directory, is to completely omit the path and simply type in the name of the file, and this will do the same thing. Now, we can also move this to a new location. So let's say I create a folder called text files, and then I move into my operating system, move the file, and if I try this now again, R will complain, cannot open connection. This is a bit confusing, but it basically means that this file hasn't been found. So what we could do now is revert back to this and enter text files. So we're back with the object that I created earlier. But what we could also do as an alternative is to use relative paths. And this basically means we use the working directory location, so the location again of the R Markdown file here. We remove all of this. We say current working location, which is indicated by the dot. And then we want to go into the folder text files and then open the file text file. And again, you can see that this worked. Now, just as a quick note, you have these slashes that separate different folders, and this will look the same if you're on a Mac computer. However, if you're on a Windows computer, we've seen that the location always looks somewhat like this, and so on. But R actually can't do anything with the backslashes. So whenever you enter a file location from a Windows machine, for example, by copying the path, you can highlight one of the backslashes, then press Control and F and replace the backslash with a forward slash. Go through it with replace. And once this is done, R can actually use the file path that you provided. Now, before we conclude today's session, I promised you that I will show you how to read in and export files. And to do this, let's load once more the MPG dataset from tidyverse. Get this to a new object. Just call this df. So we have this data frame in our environment now. And let's say you wanted to export this to an Excel file. There is a really great package for this, which you first need to install, and you install the package, go to the package tab here, hit install, and the package we want to have is RIO or Rio. Here we go, and Rio has two very simple commands that are incredibly powerful when it comes to importing and exporting data. And you can call it by using Rio and then typing the colon twice, and it has the command export. When hovering over it, we can see that export has two important arguments, which is the X argument where you put in your object and the file argument where you display your file. So let's say we want to export df, and to make this more interesting, I can also create a new folder here called data, and I want to export this to data. Second, so current directory, data, and then let's call this data xlsx, which is the extension for Excel files. And when we now go to the data folder, you can see that we have an Excel file now. When I now go and open this in my operating system, you can see that this is displayed as an Excel file, and you should remember the different columns here and the data. So the reason you want to export this to Excel, or at least the reason why I sometimes export data sets to Excel, is because I want to change something. So let's say I noticed that the Audi actually didn't have 2 liters of displacement, but it had 2.01. Then I could enter this here, save the file, and after closing it, I can go back to RStudio and use the second important command from Rio, which is Rio import. So let's just copy this and import the same thing, and when I run this now, it would simply print the data to this file, which is not what I want. I want to make a new object, so I call this new object df2. And when I open this now, you can see that everything is exactly the same, except the value that I just changed. And Rio really does a lot more than just import and export Excel files. You can basically use any file extension you want, and Rio will usually have you covered because it knows a lot of the different extensions and knows how to export them. So for example, let's say you wanted to use a CSV file for some reason. CSV files are similar to Excel files, but they are somewhat more widely used in data science because they are less likely to get corrupted. You could do this, and you can see here it exported a correct CSV file. A pretty good idea is to use RDS files, which are specific to R, and they should be used if you plan on re-importing the same data without changing it into R, because the RDS files are quite small and they don't change any attributes or anything else about the data before saving them. So by using RDS files, you can make sure that the data you exported in one script is exactly the same if you import them in another one. So here we go. Now that you know how to import and export files, you can theoretically work with your own data from now on. As I said, Rio really knows a lot of different formats. So if you have a data set that comes from Stata or from SPSS, that you downloaded from the internet in some weird format, usually Rio has you covered, and if it doesn't, please write it down and ask me in the help desk session. Now, since the book hasn't provided any homework, I want you to do something very easy, which is to get a dataset, any dataset that you like, and read it into R. And that concludes the video for today. Hope to see you next time. Thanks and have fun learning R.